Harvard astrophysicist Avi Loeb has just published a controversial analysis about interstellar visitor 3I, Atlas. He says new James Webb Space Telescope data reveals 3 strange chemical fingerprints that should not survive the harsh trip between stars. The evidence is real, the data is confirmed, the implications are staggering. Here's what makes this so controversial. Loeb's claim centres on 3 bright features in JWST's August readings. They sit at 3.4, 6.2 and 8.7 micrometers. They look like heavy organic material. That matters because these molecules fall apart easily under space radiation. Yet 3I, Atlas, shows them glowing as if they were freshly made. Think about that for a second. Space between stars is brutal. Radiation tears molecules apart. Complex chemistry doesn't survive millions of years of cosmic bombardment. That's the accepted science. That's what every textbook says. But Loeb's analysis shows these fragile molecules intact. Bright, strong, impossible. What Loeb's calculations reveal is that complex chemistry can travel between worlds intact, protected somehow, sheltered from the destruction that should have erased it long ago. The numbers push the mystery further. The object is venting water at a rate equal to a truckload every second, 40 kilograms per second. That's not a typo. A truckload of water every second. While still far from the sunday, it spreads carbon dioxide 8 times faster than water. Normal comets don't do that. Water dominates comet chemistry. Always. That's the rule. Carbon dioxide plays second fiddle. But 3I, Atlas, flips the script. 8 times more carbon dioxide than water. The ratio sits at 7.6 to 1. Unprecedented. It throws out cyanide gas at a level equal to a small city's worth of fumes each second, 4 times 10 to the 25th molecules per second. That's the equivalent of industrial pollution from a chunk of ice supposedly frozen for millions of years. Those patterns should not appear together in a natural body this far from the sunday. That's where the official explanation struggles. Loeb sees these signatures as evidence of protected chemistry riding inside the object, not on the surface where radiation would destroy it, but deep inside, shielded, preserved. The mainstream view can't account for this. NASA scientists say comets can surprise us. They point to pockets of trapped gas, deep ice reservoirs, natural explanations. Tom Statler from NASA's Small Bodies Group maintains 3I, Atlas fits known comet behaviour. Chris Lintop from Oxford agrees. They see an unusual comet, nothing more, but the data tells a different story. South African radio telescopes just detected something extraordinary. The Meerkat Array picked up hydroxyl radical signals on November 11th. These signals indicate massive water vapour release, hot jets erupting from the surface, hot jets from an object that should be frozen solid. British teams at the European Southern Observatory report the object turning slightly bluer. That's a sign of surface dust dropping away. Fresh material exposed. The object is changing, evolving right now. And that's not the strangest part. The Neil Gehrels Swift Observatory caught OH emission bursts between July 31st and August 1st. Hydroxyl radicals glowing in ultraviolet light, the kind of glow you see when water molecules get ripped apart by intense energy. Intense energy from what? The sun is too far away. The object sits beyond Mars' orbit. Solar radiation at that distance can't generate this kind of activity, not naturally. Loeb's analysis points to internal heat. Something inside 3I, Atlas, is generating energy, creating the conditions for chemistry that shouldn't exist, protecting molecules that should have died millions of years ago. The numbers don't match what they're saying. Water production sits at 40 kilograms per second. But the object hasn't reached perihelion, hasn't made its closest approach to the Sunday. It's still climbing toward peak heating, yet it's already venting like a comet at maximum activity. The carbon dioxide ratio breaks every model. Comets from our solar system show ratios of 1:1, maybe 2:1 in extreme cases. Never 8:1, never this dominated by carbon dioxide, unless the object isn't from our solar system's original material, unless it formed under completely different conditions, unless it's carrying something that changes the chemistry. What Loeb found next changed everything. The European Southern Observatory's very large telescope detected nickel in the coma. Nickel, a metal that shouldn't sublime at these temperatures, shouldn't turn to gas this far from the Sunday, yet there it glows. Metallic nickel requires temperatures above 700 Kelvin to vaporize. The object's surface sits at 200 Kelvin. The math doesn't work. The physics says impossible, but the spectrum doesn't lie. Loeb frames this gap as a question, not a conclusion. He explicitly states the data must decide. Scientific caution from Harvard's most controversial astrophysicist. Here's where it gets even more controversial. The object shows non-gravitational acceleration, an invisible force pushing it off course. Not from the Sunday, not from gravity, from something else. The acceleration measures 94 kilometers per day squared. That's powerful enough to deflect the object thousands of kilometers from its predicted path. Powerful enough that astronomers had to revise its trajectory 3 times since discovery. Normal comets show this when jets of gas push them around, but the jets should follow a pattern, strongest at perihelion, weakest when far from the Sunday predictable. Mathematical, 3i. Atlas breaks the pattern. The acceleration started early, too early. Before significant heating should have triggered outgassing. The force doesn't match the observed gas release. Too strong for the amount of material venting. The mainstream explanation requires massive unseen jets. Jets we can't detect. Jets that somehow produce force without visible gas clouds. Jets that defy the relationship between outgassing and acceleration that works for every other comet. Loeb argues this points to something else. What if the acceleration comes from a different mechanism? What if the object has structure that creates asymmetric forces? What if the protected chemistry inside relates to the mysterious push? That's not a scientific consensus. That's one expert's interpretation of anomalous data. But that's where the story gets complicated. New observations complicate both views. The asteroid terrestrial impact last alert system keeps tracking the object from Chile. Every night brings new data. The object's brightness fluctuates, not smoothly like a rotating sphere, but irregularly, chaotically, like something fragmenting. Loeb's latest calculations suggest the object might be breaking apart, not catastrophically, but slowly, pieces separating. Each piece with its own chemistry, its own acceleration, its own mystery. The James Webb Space Telescope caught hints of this in August. Multiple bright spots in the coma, not one source of gas, but several, each with slightly different spectral signatures, as if different materials are exposed in different regions, different materials that shouldn't exist together. The 3.4 micrometer feature suggests methyl compounds, organic molecules with carbon-hydrogen bonds, fragile structures that ultraviolet radiation destroys in decades, not millions of years. The 6.2 micrometer glow indicates aromatic compounds, ring-shaped carbon molecules, the building blocks of complex chemistry, the kind of molecules that need protection to survive interstellar space. The 8.7 micrometer signature points to silicates, rocky material, dust, but not ordinary dust, processed dust, dust that's been heated and cooled in specific ways, dust with a history. These 3 signatures together tell a story the mainstream view struggles to explain. Tom Statler argues natural processes can preserve complex molecules in deep ice, shielded by kilometers of frozen material, released only now as the sun penetrates the surface. But Loeb's analysis shows a problem with that model. The molecules appear too organized, too concentrated, too bright for random preservation. If they were scattered through bulk ice, they should emerge diluted, weak, barely detectable. Instead, they dominate the spectrum. They shine like fresh chemistry, like molecules created recently, or protected by something more sophisticated than random ice. What the mainstream can't explain is the combination. Any one anomaly might have a natural explanation. The carbon dioxide ratio could be primordial, the early acceleration could be measurement error, the organic molecules could be lucky survivors. But all together, all in one object, all appearing now, Loeb states the odds are astronomical, not impossible, but improbable enough to consider alternatives that challenge our assumptions about interstellar visitors. Think about what that means. If complex chemistry can survive interstellar journeys, life's building blocks can spread between stars, not just simple molecules, but sophisticated compounds, the kind that could seed chemistry on new worlds, the kind that could carry information. That's the implication Loeb won't state directly, but it hangs over his analysis. The possibility that 3I Atlas carries more than ice and rock, that it carries evidence of chemistry from another solar system, chemistry that might not be random. The British team's latest findings add another layer. The object's colour changed between July and November from reddish to bluish. That indicates surface evolution. Dust blowing off, fresh material exposed. But the colour change happened too fast, too dramatically. Normal comets change colour over months near the Sunday 3. I-Atlas changed in weeks while still in cold space. Something triggered rapid surface evolution. Something more than gentle solar warming. The Meerkat radio detection confirms violent activity. Hydroxyl radicals require energy to form, energy that splits water molecules, energy that shouldn't exist at the object's current distance. Unless internal sources generate it, Loeb's calculations point to heat from inside, not from radioactive decay like asteroids. The heat output is too high, too focused, too correlated with the chemical signatures. He frames it as an open question. What mechanism could generate internal heat? What process could protect complex molecules? What structure could produce non-gravitational acceleration? Natural explanations exist for each question separately, but one explanation that answers all three, that's what December will test. The James Webb Space Telescope has observation time scheduled after the object's closest approach on December 19th. Those readings will capture 3I Atlas at peak activity, maximum heating, maximum outgassing, maximum revelation. If the object follows natural comet behavior, the December data should show predictable patterns. Water should dominate as solar heating peaks. The carbon dioxide ratio should normalize. The organic molecules should fade as surface ice sublimates. That would confirm the mainstream view. But if the patterns hold, if carbon dioxide stays dominant, if organic molecules brighten instead of fade, if the acceleration increases without matching gas release, that would support Loeb's controversial interpretation. Here's what makes this moment unique. We've only studied 3 interstellar objects. Oumuamua in 2017, Borisov in 2019. Now 3I Atlas in 2025. 3 visitors from beyond our solar system. 3 chances to understand what travels between stars. Oumuamua showed acceleration without visible outgassing. Scientists still debate its nature. Borisov looked like a normal comet, chemistry familiar, behavior predictable, natural. 3I Atlas sits between these extremes. It shows comet-like activity, but with impossible chemistry. Natural processes, but unnatural patterns. Familiar physics, but unfamiliar results. Loeb sees this as evidence of diversity among interstellar objects. Not all visitors are the same. Not all formed the same way. Not all carry the same materials. Some might preserve complex chemistry through mechanisms we don't understand, mechanisms that protect molecules from radiation, mechanisms that generate internal heat, mechanisms that produce anomalous acceleration. The scientific community remains divided. The majority favour natural explanations, unusual chemistry from different formation conditions, preservation in deep ice, acceleration from unseen jets, each anomaly explained separately, no need for exotic interpretations. But a growing minority sees patterns that don't fit, patterns that suggest something more complex, not artificial necessarily, but organised differently than random natural processes would create. The December observations will provide crucial data. Ground-based telescopes will measure the object's trajectory precisely. Any deviation from predicted paths will reveal the true acceleration, whether it matches outgassing or requires another explanation. The European Southern Observatory will analyse chemical evolution, how the spectrum changes as the object heats, whether organic molecules survive or disappear, whether new chemistry emerges. But the James Webb Space Telescope holds the key. Its infrared sensors will peer through the coma, detect molecules invisible to other instruments, map the distribution of different compounds, reveal whether chemistry is random or organised. Loeb says that those observations will be definitive. Either they'll show natural comet processes, unusual but explicable, or they'll reveal chemistry that shouldn't exist. Patterns that require new explanations. The stakes are significant. If 3I Atlas proves natural, it expands our understanding of comet diversity, shows that interstellar objects can carry exotic chemistry, demonstrates that our models need updating but not replacing. But if the December data confirms Loeb's suspicions, if protected chemistry is real, if complex molecules can travel between stars intact, if the object shows organisation beyond random natural processes, that would force a fundamental reassessment, not just of this object, but of how chemistry spreads through the galaxy, how complex compounds survive impossible journeys, how life's building blocks might travel further than we imagined. Loeb frames this as science at its best. Hypothesis meeting data. Predictions facing observation. Controversy resolved by evidence, not opinion. The December readings will provide that evidence. Clear, quantifiable, undeniable. What scientists discover could answer the question or deepen the mystery. The object continues its approach. Every day brings it closer. Every observation adds data. The November 11th radio detection was just the beginning. More surprises likely await. The scientific tension reflects genuine uncertainty. We're watching something we don't fully understand, something that challenges our models, something that might be natural but extraordinary, or might be extraordinary because it's not entirely natural. That's the question December must answer. Loeb's analysis has set the stage, the controversial claims are public, the scientific community is watching, the instruments are ready. In 5 weeks, 3I Atlas makes its closest approach, 1.8 astronomical units from Earth. Close enough for detailed observation, close enough to resolve the chemistry, close enough to test every hypothesis. The object won't return. Its hyperbolic orbit ensures this is our only chance. One pass through the inner solar system. One opportunity to understand its nature. One moment to capture the truth. After December 19th, 3I, Atlas heads back to interstellar space, taking its secrets with it, unless we decode them first. That's what makes this breaking news. Not just the discovery, not just the controversy, but the ticking clock, the approaching deadline, the narrow window to understand something unprecedented. Loeb emphasizes this urgency in his analysis. Every observation matters. Every spectrum counts. Every data point could reveal the key. The difference between natural and extraordinary might hide in subtle details. Details we'll only see during closest approach. The mainstream scientists agree on this point. Tom Statler has telescope time reserved. Chris Lintott coordinates ground observations. Even skeptics recognise this object deserves intense scrutiny. Whatever it is, it's unusual enough to demand attention. The question everyone's asking is simple. What is 3I Atlas carrying? Ice and rock from another star? Complex chemistry that survived millions of years? Evidence of processes we don't understand? Or something else entirely? Loeb won't speculate beyond what data supports. But his analysis opens doors that were previously closed. Possibilities that seemed impossible. Questions that demand answers. The protected chemistry is real. The James Webb Space Telescope confirmed it. Multiple teams verified it. The spectral lines are unambiguous. Complex organic molecules exist where they shouldn't. The anomalous acceleration is measurable. Precise tracking shows deviation from gravitational predictions. The force is small but persistent. It's changing the object's path in ways that matter. The internal heat is implied by multiple observations. Hydroxyl radicals need energy. Nickel needs temperature. Early activity needs a trigger. Something inside 3I, Atlas, generates that energy. These facts are not disputed. What's disputed is their meaning. Natural but extraordinary. Or extraordinary because unnatural. December 19th approaches with that question unanswered. The world's best instruments stand ready. Scientists on both sides of the debate prepare their predictions. Loeb says protected chemistry will persist. Statler says normal patterns will emerge. Someone will be wrong. Someone will be right. The data will decide. What scientists find could settle the debate. Could confirm that interstellar space preserves chemistry in unexpected ways. Could reveal mechanisms that protect complex molecules across impossible distances, or could show something even more extraordinary, something that changes how we see our place in the universe, something that suggests chemistry doesn't just randomly survive interstellar journeys, something that hints at organisation beyond natural chance. Loeb frames this as a question, not a conclusion. He says the data must decide. December will bring that data, clear, unambiguous, final. Until then, 3I, Atlas keeps its secrets. Venting water at impossible rates, glowing with protected chemistry, accelerating from mysterious forces, a visitor from beyond, carrying molecules that shouldn't exist. The evidence is real, the data is confirmed, the implications are staggering. What those implications mean will be determined by observations scheduled for December 19th and beyond. The James Webb Space Telescope will make the final assessment. Ground observers will provide supporting data. Together, they'll answer the question that Loeb's analysis has raised. Is 3I Atlas just an unusual comet with exotic chemistry? Or is it evidence that complex molecules can travel between stars in ways we never imagined possible? The scientific community waits. The instruments are ready. The moment approaches. What